Hi, I am Pradeep Mishra. Welcome to my SPSS session, step-by-step guidance to SPSS. Today in this video, we will talk about how to enter the data into SPSS and generating new variables in SPSS. Generally, generating new variable in SPSS require a fair gamut of knowledge of scale of measurement. So before going to the entry of data and generating new variables, I will talk about the scale of measurement and what is the role of this scale of measurement in SPSS and what role it plays while entering the data. Generally, there are four scales. One is nominal, ordinal, interval, and ratio. The knowledge of these four scales are required if you want to generate a variable in SPSS. So what is this scale of measurement? Scale of measurement is a technique to know the relationship between what is being measured and the number which represents what is being measured. That is known as the scale of measurement. For example, we have some data points like mathematics score of children in class 8, in class 7, class 6, whatever it may be. The score of children in other subjects, the temperature, these are the data points. If these are the data points, how we are measuring that data points? Mathematics score in terms of what? In terms of number. So mathematics score means we are giving some numbers. Here, what is being measured? This is mathematics score we are measuring. And in order to measure that variable, we are assigning some numbers so that it represents that variables. Number is representing that variables. So this is known as the scale of measurement, or we can say it level of measurement. So let me discuss about nominal variable. First is nominal variable. So what is this nominal variable? Two things are equivalent in some sense, are given one name, but having different possibilities. For example, gender. It has two subcategories, male, female, and even three subcategories, male, female, and transgender. So this variable has one name, male, female, and transgender. They have, in some sense, they are equivalent. They belong to gender. In some sense, they are equivalent, but different possibilities. Male, female, and transgender, they have different possibilities of gender. So in this sense, it is called nominal variable. For example, if we want to categorize the players of soccer team from 1 to 11, if there are 11 players in a team, if you want to name them 1, 2, 3, 4, 5. So this naming, it doesn't represent the place value of that number, rather it is the position of the number. For example, we cannot say if we are assigning 1 to the forward player, 2 to midfielder, 3 to goalkeeper, for example. If this is the nominal case, if the nominal scale of measurement, if the variable comes under nominal scale of measurement, we cannot say if we will multiply forward with midfielder, we will get something else. That is not the case. So in this case, in only the nominal scale, we will assign some numbers for the sake of categorization. So here, the number doesn't represent its place value, rather simply it tells about the position. You can take gender, you can take socio-economic status, rich, poor, mediocre category. So these are the categorization, and we are denoting some numbers to these categories. So that will come under nominal scale. Now, second, this is ordinal. Ordinal is, it has two properties. One is naming properties. We will name the subcategories in ordinal. And in the meantime, in ordinal scale, what we are measuring, that we will name them in the meantime, the attributes of that particular variables will be ordered in a certain, on the basis of some logic. Here in ordinal scale, if I will talk about its properties, two things will be there. One is definitely categorization plus order. This is called ordinal variables. So ordinal scale tells us, not only tells us whether an attribute, whether an action has happened or not, rather it also tells us in what order a certain thing has occurred. And that is this order is one of the additional component in ordinal scale. For example, in Olympics, 5 sprinters they were competing, and the first sprinter completed the race in 7 minutes. The sprinter who came in the second position, he completed the race in 9 minutes. This is minutes. This is minutes. And the third runner who completed the race, approximately she took around 13 minutes. So the first, second, and third, these are categories. These are the naming categories. So these three, first, second, third, comes under nominal. These properties are nominal. Naming sake. But this naming has been done on the basis of some order, and that is the logical order. What is the logic here? 7 minutes, because the first sprinter is quite faster than the second and third one, so that is the logic. So when there will be some categorization and plus order, logical order, so that variable will come under ordinal scale. These both nominal and ordinal scale of measurement, they are coming from one category, that is categorical variable. Let me tell it, categorical variables. In categorical variables, two things will come, that is the nominal scale and ordinal scale. The variables fulfilling the properties of nominal scales and ordinal scales are categorical variables. So we will proceed to the next level of scale of measurement, that is third, this is interval scale. Interval scale has three properties. What are the three properties? One, definitely categorization. Definitely it will be there. The property of nominal scale plus order. Definitely order will be there, plus interval, equal interval. If a scale will fulfill these three properties, then we can say the variable comes under interval scale. For example, if you will rate me, if you will rate my video on a 5-point scale from highly dissatisfied to highly satisfied. Let me highly satisfied, satisfied, not sure, then dissatisfied, highly dissatisfied. Let me highly satisfied, let me score 5, 4, 3, 2, 1. In this case, the difference between these two categories is identical to the difference between these two categories. So, in this case, the difference between each category is equal. The difference here is 1. In this case, the difference between disagree and highly disagree is identical to highly disagree and highly satisfied and highly satisfied. Sorry. In this case, the difference is equal. Now the scale, now the variable fulfills three conditions here. One, categorization. Definitely categorization is there. Highly satisfied, satisfied. These are the categorization. These are the different categories. Order. It has been arranged in a order 1, 2, 3, 4, 5. If someone is highly satisfied, then definitely I can say, and if someone is highly dissatisfied, so I can say yes, if 30% people are highly satisfied and only 70% people are highly dissatisfied, then I need to think on it. I need to improve the lessons, right? So in that sense, it has meaning, right? So it has order. Then equal interval. This property is met, this property is met, and equal interval. Again, the difference between these two options is identical to the difference between these two options. So this kind of variables, they come under interval scale. And in most of the cases in social science research, though if we will technically, I will speak whether again it is an ordinal scale, but still looking at the difference and other properties, we can call it as interval scale. And most of the research that we are doing in social science research, most of the scale comes under interval scale. So next to it, the last one is the ratio scale. This is ratio scale, and this is one of the robust scale in statistics. It has, let me tell you, 4 properties. It has all the properties of previous 3 scales: nominal scales, ordinal scales, and interval scales. And in the meantime, it has another properties, that is 0 reference point. So categorization is there. Then second property, this is order is there. C, equal, interval is there, and the fourth one is zero reference point. Which means the ratio of two different attributes of a certain variable is also meaningful in this case because it has zero reference point. Some of the example of ratio scale is a sprinter who runs 100 meter in 1 minute is 2 times faster. A sprinter runs at a speed of 100 meter in a minute. It's 2 times faster than a sprinter who runs 50 meter in a minute. Is it making any sense? But in this case of interval scales, we cannot say this. What we cannot say this? If there are 5 scale 1, 2, 3, 4 and 5, the person rated 5, we cannot say 5 times more satisfied than the persons rated highly dissatisfied. We cannot say because exactly we do not have zero reference point. But this is possible in ratio scales. A sprinter who runs 100 meter in a minute is 2 times better than the sprinter who runs 50 meters in a minute. In this case, the ratio of the attribute is also true. 100 divided by 50 equal to 2. Exactly 2 times he is running faster than his counterpart. In this case, we can say. So, all these 4 properties are present in ratio scale. This categorization is there, order is there, equal interval is there. We can derive the intervals also from that number because as we have a zero reference point and zero reference point is there. So perfectly, the ratio scale is one of the robust scale in statistics. So this interval scale and ratio scale are coming under continuous scale of measurement. This is continuous scale of measurement or continuous variable because due to the numbering properties. So now let me summarize it. Variables, 2 kind of variables. One is categorical, one is continuous. In categorical, 2 kind of variables will come in 2 different scale of measurement. One is nominal and ordinal, and here interval and ratio. Okay, so these are the concept of the basic concept of scale of measurement. But when we will go to statistics, then we go to SPSS. We will find only three scales there. One is, this is nominal. Two is ordinal, and third is scale. And in SPSS, scale means it includes both interval and ratio. So three things you will find: nominal, ordinal, and scale. Scale means it includes both interval and ratio. Then let us do it in practical.